right, so yesterday we added in sine and cosine, and then we just practice. So today we're going to kind of do something new, add a little bit more to it. We're going to add tangent at the end of the hour, and at that point we'll have it all filled in. Another big day today. Thanks for joining me. The new thing that we're going to talk about today are what we call identities. Identities are two things that are identical. All right. And these are what we call the fundamental identities, meaning they're kind of the key ones, the main ones that we deal with. And so they're just equivalent relationships with the 6 trig functions. Now, did you know there were 6? Yeah, there's not 3, there's 6 trig functions. So in this chapter, we just talk about the fundamental, but we have an entire chapter, chapter 5, where we do a lot more with the identities. All right, so we start off with the reciprocal identities. And I do have this remember sticky note, which means you do have to know these. They're fundamental. You gotta know them. All right, so what we want to think about here and is just the reciprocal means you flip it, you put it under 1. And so we're familiar with like the sine. Well, the reciprocal of sine is actually a cosecant. That's what that stands for, cosecant. I should probably write that because we always abbreviate it, but I don't know that I ever write it. So that is going to be, it's spelled like this, cosecant. This is secant, and then this is cotangent. And these are the 3 new ones that are simply reciprocals of the one we want. So for instance, if the sine of a particular angle is 1/2, then the cosecant of that angle would be a 2/1. That's all you do is you just do the reciprocal. Okay, so that means the sine is equivalent to 1/cosecant, and cosecant is equivalent to 1/sine. They are reciprocals of each other. So you have to remember how they match up. Sine goes with cosecant, cosine goes with secant. Tangent obviously is going with your cotangent. All right, so to help you remember how they match up, I always remember that there's always one co and one not co. So tangent goes with cotangent. Cosine already has a co, so it must go with just regular secant. But sine doesn't have a co, so it's got to go with cosecant. No particular meaning to that. It's just how I remembered it. Okay. The other fundamental identity that we use a lot is tangent and cotangent. Now, they are reciprocals of each other, but I think more importantly, let's start with tangent and then we'll come back to cotangent. If you remember from SOHCAHTOA that tangent is opposite over adjacent. Well, if you think about, if I were to write sine over cosine, I kind of don't have a lot of room. I'm sorry, I'm going to come over here. You don't need to write this stuff down, but the sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. And instead of dividing by a fraction, we would multiply by the reciprocal. And lo and behold, your hypotenuses would cancel out, and all you have is opposite over adjacent, which is really what tangent is. All right, so that's kind of the reason it works. Ultimately, we need to know that tangent then is equivalent to taking your sine and dividing by your cosine. And since cotangent is the reciprocal of tangent, you'll see that these just are the reciprocals of one another as well. Okay, so for today, you can kind of have this list, this little cheat sheet to look back at, but you'll use these often enough that you won't have to look at that every time. So we can use the fact that these are reciprocals or quotients to figure out the actual value of a cosecant or a secant. Now, you don't have to know these off the top of your head by any means, but you have to be able to think your way through it. So let's start with this 13 pi over 6. I'm looking for the cosecant of 13 pi over 6. Well, the first thing I want to do is figure out where 13 pi over 6 is. So I'm going to sketch us because I can't envision over a video. I'm going to draw it. But ultimately, I'm thinking, all right, that's more than one time around. So if I'm doing 6, here's 6, 6, 12, 6. So 13, 6 lands right here. Okay. So really, since I'm doing cosecant, I'm really going to do sine first. So think about sine. Sine is your y value. You would be up the short leg. So sine would be 1/2. And if the sine is 1/2, the cosecant is the reciprocal. It would be 2/1. Really, we would just write 2. No reason to write that as a fraction. Okay, let's try again. On this one, I have to find 11 pi over 2. All right, 11 pi over 2. That's a lot of times around. All right, so remember half a pi is right here. So there's 1/2, 2 halves, 3 halves, 4, 5, 6, 7, 8, 9, 10, 11. Does this look familiar from our previous notes? Yeah. All right, so here's 11 pi over 2. Now, they want me to find the secant of 11 pi over 2. Well, secant is the reciprocal of cosine. So really what I'm going to find is the cosine. Cosine is my x, my horizontal movement, and looks like I'm not moving horizontally. My cosine is actually 0. What's the reciprocal of 0? Well, if you did the reciprocal of 0, it would be a 1/0, and that's problematic. We can't have 0 in the denominator. So this actually is considered undefined, and that will certainly happen sometimes. All right, let's keep going. Secant of 11 pi over 3. So I have to find my 11 pi over 3. Just for the fun of it, let's go ahead and do this a different way. Just because maybe you're more comfortable instead of drawing it out, maybe you need to subtract. So I'm going to subtract 2 pi until I get something that I'm familiar with. So you have 11 pi over 3, 2 pi. If I subtract 2 pi, that would be 6 pi over 3. Okay, that would take me to 5 pi over 3. Is that on your unit circle? Sure is. 5 pi over 3 is right here. All right, so I only had to subtract 2 pi once, so then I landed right here. All right, so now the cosine is what I'm really looking for because it's the reciprocal of secant. And your cosine right here is how far over. That would be over the short leg, down the long leg. So since my cosine is the short leg, it's 1/2. And the reciprocal of 1/2 is 2. We're getting lucky here. Okay, let's try one more. The cosecant of negative 5 pi over 3. All right. Do you want to do the same thing, I guess, on this one? We'll try it. This time it's negative. So I'm going to have to add, this is thirds again. So I'll add a 6 pi over 3. That's going to take me to something that's positive, to just a 1 pi over 3. Do you know where 1 pi over 3 is? It's right here. So I am looking for the cosecant. That is the reciprocal of sine. And sine right here would be how far up you're going, and that would be your long leg here. You'd be up, you'd be over the short leg and up the long leg for that triangle. So the sine value, okay, this one's going to be a little trickier. The sine of pi over 3, or negative 5 pi over 3, would be equal, I'll just write pi over 3 for now, to root 3 over 2. You have to do the reciprocal of a root 3 over 2. So that's going to be a 2 over root 3. But then we have to rationalize. Root 3, root 3. So 2 root 3 over 3, and it does not reduce. So that's what I have right here, 2 root 3 over 3. Now you're going to come across the same numbers over and over, just like we got this 2 a couple times, because that's the reciprocal of 1/2. This is the reciprocal of root 3 over 2, so we will come across that a lot as well. Don't have to remember it. You'll just notice it probably. All right, so here's a different way that we can use this. It says, given two trig values, find the value of each of the remaining trig functions. All right, so I'm using my fundamental identities to do this. And the first two are going to be easy peasy because if they want me to find the cosecant, well, that's just the reciprocal of sine. So all I've got to do is flip it. So the cosecant of whatever angle T is 5/2. And the secant is just the reciprocal, so that would be 5 over root 21. But on this one, we do have to rationalize, but that's okay, not too hard. 5 root 21 over 21. In fact, some of you, I bet, can rationalize in your head. And if you can, go for it. I don't need to see the work for that. All right, so now that takes us to the tangent. They're not quite as easy because I don't have one or the other. I can't do the reciprocal. But remember, the quotient identity says that tangent is just sine over cosine. So what I have is that whole nested complex fraction thing. We have a 2/5 over a root 21 over 5. And then you bring this up and multiply by the reciprocal. 5s are going to cancel for us. So we're at 2 over root 21. But we got to rationalize. So get this out of there. And now final answer for this one is going to be 2 root 21 over 21. What a mess. Okay. The cotangent is the reciprocal of that one. Well, I could do two things. I could do what I just did here, only do it the other way, because remember, cotangent is cosine over sine. Or I could just do the reciprocal of the tangent. I could do that. But honestly, I don't think I would do the reciprocal of this stage. I would do the reciprocal right here before I rationalized it. Because if I do the reciprocal of this, it will rationalize itself by flipping it. So I'm just going to call it root 21 over 2. And then I'm just done. So there's one that you have to work a little bit harder on. The others should all play out real fast for you. All right, so this is one scenario where they give you two trig functions. You have to find all the rest. All right, so I got bored with those identities. I figured we need some more, right? These are called the Pythagorean identities. All right, I'm going to talk about this first one. And if you look at our unit circle, remember, and you could just draw any angle in here, doesn't matter. Recall that in the unit circle, the hypotenuse is always 1. But also remember that how far over is your cosine and how far up is your sine. So does this identity actually make sense why that would work? Because you're just doing Pythagorean theorem on that triangle. So it is worth noting that it's the cosine value squared. So that's why the squared goes in between here. Don't put the squared out here because that would square the angle. And that's not what we're trying to do. We're trying to square the cosine value. All right, so we've got this. These are alternate versions of it. If I were to use some of my other identities and change out the sign for like a 1 over cosecant, I'd end up down here with this one. Or if I change this into a 1 over secant, I'd end up at this stage. Not going to show that. I know you're ready to keep moving, so I'm going to keep moving. But these are just alternate versions. They're all called Pythagorean identities. This one's the main one, but we'll run across these a bunch as well. All right, so this says, given the sine of theta is 3/5, and you know that theta falls between 0 and pi over 2. Okay, this is a fancy way of telling you what quadrant it's in. Can you look at that and tell me what quadrant we are in? I'm actually going to write it so we don't forget. It's in quadrant 1. And by being in quadrant 1, what they're telling you are the signs. Okay, everything's positive in quadrant 1. Got it. They want us to find the value of cosine. They gave us sine. They want us to find cosine. Now, the original identities didn't really have a nice connection, but the Pythagorean identities do. So what you're going to do is remember that the identity is sine squared theta plus cosine squared theta is equal to 1. I know what sine theta is. It's 3/5. So I'm going to write 3/5, but I have to square it. Plus cosine squared theta equals 1. Now we're just doing some algebra. Let's subtract the 3/5 squared. So I'm going to subtract 9/25. So it's going to look like this. And in fact, my 1, I'm going to change to 25/25 so that I have a common denominator. So cosine squared theta, 25 minus 9 is 16/25. Square root both sides. Oh, look how lucky we are here. Cosine theta is equal to 4/5. Now, you should be saying, oh, Miss Barry, you forgot your plus or minus. I did forget my plus or minus, except that we know that it is in quadrant 1. And cosine and everything is positive in quadrant 1. So don't put the plus or minus. If it was in a different quadrant, it might only be minus. So pay attention to what quadrant to decide what to do with that. And I'm just throwing some problems at you here that you can use these identities to help you find missing things. All right, so this one says, let theta be an acute angle. All right, just another way of saying, hey, this is going to be in first quadrant. Acute angles are in first quadrant. And you know what the cosine is. It is 0.8. They want you to find the value of sine and the value of tangent using our identities. All right, got a hint for you. They're saying, hey, try the Pythagorean and then do the quotient. All right, so since they gave me the cosine, I want to use the Pythagorean identity that has cosine in it. So that would be the sine squared theta plus cosine squared theta is equal to 1. I'm looking for the sine squared theta. I know that this is 0.8 squared equals 1. All right, I'm just going to go to my calculator because I already know that it's going to end up a decimal anyway, and I'm just going to do 1 minus 0.8 squared. And I get a 0.36. Now I'm ready to square root both sides. The squaring and square rooting undo, so I'm at sine of theta, and do you know what this is going to be? 36 should have kind of given that away. It was a 0.6. All right, so they wanted me to find sine, got it, but they also want us to find tangent, and my hint here is now use your quotient identity. Your quotient identity says that tangent is sine over cosine, and I now know sine and cosine. So tangent of theta would be my sine over my cosine. Put in those decimals. And let's go ahead and just maybe get a decimal on that. If you divide that out, you find out that the tangent of theta is 0.75. And you've got them both. All right, I have one more of these. When you're doing your homework, keep your notes out because there's a lot of them that are kind of the same setup. They'll give you the same things, just different numbers. All right, so on this scenario, again, theta is an acute angle. Acute angles happen in the first quadrant. So if you want to write quadrant 1, that just means everything's going to be positive for us. We know what tangent is. It's 1/3. We want to find the value of cotangent and the value of secant using trig identities. And again, I'm giving you a hint. You don't get hints in my math lab, but here it is. It says try using the reciprocal identity. Because look, they gave us tangent and they want cotangent. Those are reciprocals of one another. That's easy. Cotangent of theta is just going to be a 3/1. I'm just going to write a 3. Don't bother writing it over 1. All right, so that one was the easy one. Now they want me to use Pythagorean identities. Since I'm looking for secant, I have to look back at the Pythagorean identities that use secant. All right, so that would be the one that goes along with tangent, which is very convenient. So it's 1 plus tangent squared theta equals secant squared theta. Now, I'm not sure. I can't go back to that previous slide, but sometimes you'll see the 1 in front. Sometimes you'll see the tangent squared in front. Doesn't really matter. You're just adding those two together. So now I'm going to write 1 plus tangent is 1/3, but I have to take my 1/3 and I have to square it. Equals secant squared theta. All right, this is going to be a 1/9, which means I want to call this 9/9. So I have 10/9 is equal to secant squared. So I'm going to square root both sides, and I am left with secant theta. Remember, everything's going to be positive, so I don't have to do the plus or minus on this one. Square root of 10 over 3. And we're done. Okay, so just some nice examples of using those identities, helping you have those stick in your head a little bit better. All right, one more thing. We need to add the last thing to our unit circle. We need to add tangents in. Okay, so this is not too bad, honestly. Let's just start with some of the easy ones. You think of all the quadrantal angles, and they all have zeros and ones. Or maybe it's a 1 and then a 0. So we already learned, and the reason we do it here is because we have learned that tangent of theta is really just the sine of theta over the cosine of theta. So all I'm going to do is use my existing ordered pairs that I already have on my unit circle and always put the sine over the cosine and then try to reduce if I can. So I'm putting my y value over my x value as I do this. It'd be nice if I had my other unit circle here so that you can see that better. But you should not be putting this in your notes. You're putting it on your unit circle. And you could be getting a new color if you would like. I'm going to use red. Okay, so looking at your ordered pair, you know that right now that this is a 1, 0. So what we're doing is we're putting the sine over the cosine. That's going to be 0 over 1. And 0 over 1 is 0. But up here, when you put the sine over the cosine, you have 1 over 0. You can't have 0 in your denominator. This is actually undefined. Okay, so now when you're over here at 180 or at pi, your ordered pair is similar to this ordered pair, only that the 1 is negative. But I'm going to be putting the y over the x, so that's still going to be a 0. When you're straight down, it sort of matches your one that's straight up. You're going to be at undefined because you're going to end up with a 0 in your denominator. Now, this isn't really about slope, but this is how I always remember which ones are 0 and which ones are undefined. Because remember, the slope of a vertical line is undefined. Slope of a horizontal line is 0. Just a little trick that I remember that with. Okay, and as simple as those were, those aren't even the easiest ones. The 45s are the easy ones because your sine and cosine are the same number. And when you put the same number over itself, you just end up with a 1. So these are all going to be 1s, except that some of them will be negative. Now, if your sine and cosine are the same, sine, S-I-G-N, sine, then you're going to have a positive. So in this quadrant, they're both positive, and in this quadrant, they're both negative. So I get a positive 1. But in the other two quadrants, I'm going to end up with a negative 1. Okay, next thing. This is where it gets a little bit trickier. So you have to look at what your fractions are. I'm going to get rid of some stuff here so I can write better. If you think about this one right here, Your sine over your cosine is going to end up a 1/2 over a root 3 over 2. And then when we flip this up and change it to a 2 over root 3, the 2's cancel, and I have 1 over root 3, which I then need to rationalize. So I get a root 3 over 3. All right, that took a little bit of work, but I'm just going to remember now that the tangent is root 3 over 3 on this version of my triangle. The one where the sine value is the short leg and the cosine is the long leg, because I'm going to always then have a 1/2 over a root 3 over 2. So where do these long triangles go? Well, you have one right there. You have one over here. You have this one down here and this one down here. So all of these will have the same tangent value because their triangles are all the same. The only thing that's going to change is whether it's positive or negative. So same deal as last time. Anytime the signs are the same, which happens in the first and third quadrant, then you're going to have, oops, that's over 3. And anytime your signs are opposite or different, then your tangent will be negative. So in the second and fourth quadrant, your tangent is negative. All right, almost there, so close. All right, last thing would be the tall triangles. The tall triangles are right here. And in these, you're doing sine over cosine. Sine is the long leg, cosine is the short leg. So that's a root 3 over 2 over 1/2. Bring it up and flip it. This actually plays out a little nicer. The 2's cancel and we just get root 3, just root 3. All right, so that means all of these are root 3's because these are your tall triangles. Tangent is going to be positive in the first and the third. It's going to be negative in the second and fourth quadrant. And we've got it. Whew, we're done adding stuff. All right, now one quick thing to help you. This is my last slide, and then we are just going to practice it in class. But I guess just a little hint, since you're not in class for us to practice or for me to give you this hint. The well, I guess you got to just remember your 45s have the same sine and cosine, so they're all 1s. I already gave you the little trick with the slope for the zeros and the undefines. So how do you know which ones of these? Well, here's my little trick. If you'll notice the radian measurement for all of these root 3's, the radian measurements are all over 3. If you look at the radian measurement for these, they're all over 6. So in my head, I think, oh, 3 and 3 makes 6. So the 3 and 3 are over the 6. The root 3's are over the thirds. Just a little trick. Okay, now we're ready for the last set of flashcards. Do the sine, cosine, and tangent. Include them all. Keep practicing, practicing, practicing. It will come to you. I promise it will. The more you practice, the quicker you get familiar with it and it makes sense in your head, the easier it goes from here. I promise. Spend the time now. All right. Thanks for joining.